Okay, just take a look around you for a second. Your phone, your smartwatch, maybe even your car. They all have this little secret in common. A tiny, completely invisible engine that, well, it pretty much powers our entire modern world. Today, we're going to pull back the curtain on the one piece of tech that has quietly become the foundation of, well, everything, the ARM processor. Now, to really get a grip on just how big of a deal this is, let's start with a bit of a puzzle. Picture a smart water meter stuck out in some remote field. How on earth can that thing run and send data for more than a decade on a single tiny battery? I know, it sounds completely impossible, but stick with me because by the end of this, you'll know exactly how it works. So, to solve that little puzzle, we've got to rewind the clock a bit. The story of ARM is really the story of computing itself, and it's this incredible journey from room-sized giants to something that fits on your fingernail. I mean, the very first computers were absolute monsters. They filled entire rooms and just guzzled electricity like there was no tomorrow. Today, that exact same processing power, and honestly a whole lot more, is packed into a tiny little chip called a microprocessor. It's the brain of the device, you know? And the revolution that shrunk it down to fit on your fingernail? Yeah, that was pretty much led by ARM. So what is this tiny brain, really? The best way I've found to think about a microprocessor is to imagine it's not just one thing, but a whole tiny, bustling city working at a mind-boggling speed. Right at the heart of this city, you've got the CPU, the Central Processing Unit. Think of it as City Hall. This is the command center. It's making every single decision, running all the calculations, and executing every instruction that makes your device do, well, anything. But of course, City Hall can't just run on its own. It needs information, right? And that's where memory comes in. It acts as the city's library and its warehouse. It's where all the data, all the apps, and the operating system are all stored, just ready for the CPU to grab in an instant. And finally, no city is an island. It has to have ports and borders to interact with the rest of the world. And that's the job of the input/output, or I/O. It's how the processor talks to everything else, the screen, the camera, the Wi-Fi antenna. It's the city's connection to you. Now, here's the thing. Most processors are built like these massive, sprawling, really complex cities. But ARM City is different. It's built on a radically simpler and way, way more efficient philosophy. And that, right there, is its secret. The secret has a kind of nerdy name. It's called RISC, which stands for Reduced Instruction Set Computer. But the name tells you everything you need to know. Instead of using these big, complicated commands, ARM processors use a really small set of super simple instructions. And simpler instructions mean they can be executed incredibly fast while using just a tiny sip of power. To really see why this is a game changer, just look at the contrast. Older processors used what's called a complex instruction set. Think of it like taking one long, difficult, and really energy-guzzling road to get somewhere. ARM's RISC approach? It does the exact opposite. It breaks down those big tasks into a series of short, simple sprints, and it gets the same job done with way more speed and way less power. And this one simple idea completely changed everything. ARM actually started way back in the 1980s with a company called Acorn Computers, but its big break came in the 2000s. Its crazy efficiency made it pretty much the only choice for the very first iPhones. And today, ARM architecture is literally everywhere, from the phone in your pocket to Amazon's massive data centers. So why did basically every business jump on the ARM bandwagon? Well, it all comes down to efficiency and flexibility. That low power use saves a ton of money on electricity bills. The architecture can scale from tiny little sensors all the way up to huge servers. But the real kicker is ARM's business model. It doesn't make chips itself, not like Intel. Instead, it licenses its blueprints, which lets companies like Apple and Samsung create their own custom processors, perfectly designed for whatever they need. But the ARM story actually goes a lot deeper than just our phones. While the big, powerful processors get all the attention, there's this unsung hero in the family, and it's powering the huge, sprawling Internet of Things. It's called the Cortex-M. So, the Cortex-A series, that's the beast inside your smartphone. But the Cortex-M is designed for a totally different world, the world of what we call deeply embedded devices. So think smart thermostats, medical sensors, robots in a factory. These are all places where power is extremely limited and efficiency is absolutely everything. The Cortex-M has a few superpowers that make it perfect for this stuff. First, it's deterministic, which just means it's perfectly predictable. For something like a car's anti-lock brakes, you need it to respond at the exact same time every single time. No delays, no excuses. Second, it has low latency, meaning it can wake up from a deep sleep, do its job, and go back to sleep almost instantly. And finally, it's just really easy for engineers to work with, which helps them create tons of new smart devices fast. Okay, so here's the crucial part. All of this super specialized, ultra-efficient technology leads to some really, truly astonishing results out in the real world. So let's finally connect all these dots and get back to our opening question. Here it is. Here's the secret. That smart water meter's brain isn't running all the time. Not even close. In fact, it spends over 99% of its entire life in what's called a deep sleep mode, where it uses almost zero power. It wakes up for just a fraction of a second, takes a quick reading, sends the data off, and bam, it's immediately back to sleep. And this is the payoff of that extreme efficiency. By spending nearly its entire life asleep, that one little device can run on one tiny battery for 15 years. That's the solution. The secret isn't a bigger battery. It's a way smarter and more frugal processor. And look, this isn't just about utility meters. This is the exact same principle that lets your smartwatch last for days. It's why your phone can actually make it to bedtime, and it's why huge companies can save millions on energy costs in their data centers. This incredible efficiency is what makes it possible to put a little bit of intelligence into almost any object you can possibly imagine. It really is the invisible engine that has completely changed our world. And it leaves us with one massive question. As we start to connect billions and billions more of these tiny, efficient brains to the internet, what are they going to unlock next?